Hi, this is a probability lesson, and in this lesson we're going to talk about the different types of probability, theoretical and experimental. Alright, let's look at theoretical probability. Theoretical probability is based on an item or situation only, not an experiment. Okay, it's not got any actions. It's what you would expect to happen, and it does not require any manipulation of the object or the item. And it's calculated by dividing. And what you divide is what you're looking for divided by the total possible outcomes that can happen. That's how you find your probability. Your answer, let me go back just a second. This answer here, when you divide, it will always be a decimal, and it'll be between 0 and 1. Okay, so calculate the following probabilities given a six-sided number cube. All right, if you just look at this number cube over here and think about what can possibly happen, all we're going to get are the numbers 1 through 6. That's it. We can land on a 1, we can land on a 2, we can land on a 3, 4, 5, or 6. And so now let's look at the probabilities. Okay, remember, what you're looking for divided by the total possible outcomes. So let's just think about 1 through 6. What are the possible outcomes, or what is that total possible? Okay, so we're going to look for the probability of getting a 1. How many 1s are in 1 through 6? Well, there's just one of them. And how many different things are there? There's 6 of them. So I did this out of order. So we're going to look at a 1 and or a 3, odd numbers and even numbers. Okay, so back to my 1 through 6. All right, we had 1, 1, and there's 6 total. Okay, when we're looking here at this one, a 1 or a 3, then we look at both numbers. It means add them up. Add not the numbers themselves, but the items. So we can get a 1 and we can get a 3. So there's 2 items out of 6 that we can possibly get, and then 2 out of 6 were reduced to be 1/3. All right, what about odd numbers? Okay, remember, odd numbers are numbers that are not divisible by 2. And so in this case, that's going to be 1, 3, and 5. So that means there's 3 of them that we can get. So we can get 3 out of 6. Whoops, I went too far. 3 out of 6, and that gives us 1/2 chance, or 50-50 chance of getting an odd number. Because there's an even number up there, our even numbers would be 2, 4, and 6. Again, 3 out of 6, so we would have 1/2. All right, now we have this cube. So let's look at what can possibly have, I'm sorry, I said cube. We have this spinner. What can possibly happen if we spun the spinner around? Well, we could land on a red, a blue, or we can land on a red, a blue, a green, and a yellow. So now we're going to calculate some probabilities that could happen. All right, so what if we look at red? Red is how many sections on our spinner? Well, there's just 1, and how many total sections are there? 4. So there's only 1 out of 4 chance that we're going to land on a red. All right, blue or yellow? Well, that means 2 of them, so we're going to have 2 out of 4. And then, of course, 2 over 4, or 2 divided by 4, will reduce to 1/2. Not green. Okay, so we're looking at the colors that are not green. Well, let's just count them. There's only 4 to deal with, so not green would be 3. So there's 3 out of the 4 that are not green. And then purple. Probability of getting a purple on this spinner? Well, there's not a purple up there, so our probability of getting a purple would be 0. There is no chance we're going to land on a purple in that spinner. All right, that was theoretical. It was based on the objects. Now, experimental probability is based on an experiment. So you either have to perform the experiment to get the data, or you have to be given the data. All right, so it's going to be based on experiment. It actually happens, requires work to be done, and records. You must record what happens in an experiment or use the data already provided. And again, it's calculated by dividing. The only difference is what you're looking for is on top, but how many times you perform the experiment is on bottom. Your total trials are on bottom. So let's see what that looks like. All right, create the probability based on the data provided. So we have a number cube. All right, so we've been given a chart telling us our different numbers that could have possibly happened and then the times we hit those numbers. All right, so we need to find these probabilities based on this data. Now, if you remember back in our theoretical, the probability was just on the dice itself or the number cube itself. This time it's based on this chart. So there's a little bit of work involved. I have all of these different numbers, and now I need to know, because I'm looking at total trials, how many times did we roll this dice? And so we rolled it 20 times. If you count them, you end up with 20 different times. So our bottom number is going to be 20. So if we look at how many times we rolled a 1, well, count the little marks. We rolled a 1 3 out of the 20 times we rolled it, or we landed on a 1 3 times. All right, a 1 or a 3, again, you count all of those, both of them. So 3 for the 1s and 2 for the 3. So 3 and 2 is 5. So we landed 5 out of 20 times, which would reduce to be 1/4. Odd numbers. Okay, so we've got to add up 1, 3, and 5. So we did 1, 3 plus 2 plus 1. So we got 6 out of 20 times, and 6 out of 20 reduces to be 3 out of 10. All right, and then our evens. Well, if our odds were only 6 and you have 20 times, you can think about what that means. Or you can count them, but you count 2, 4, and 6, and that is 14 out of 20, and that would reduce to be 7 out of 10. All right, now we have a spinner. We're going to calculate these probabilities based on our data, not on our spinner. The spinner is done because we've already performed all of this. So now we need to look at how many times we spun the spinner. Say that a couple of times. Spun the spinner. And we spun it 25 times, 25 spins. And notice I don't really have the colors listed here, so if you're following along and your paper's not in color, go ahead and write them. It's red, blue, green, and then yellow. Okay, so a probability of getting a red. Well, we got it 10 times. They were nice to us this time and gave us numbers instead of tick marks. Either works. All right, so 10 out of 25. Reduce that by 5 on each the numerator and the denominator, and so we ended up with 2 out of 5 times. Blue and yellow, so that would be 5 and 3, so we would have 8 out of 25, and that does not reduce. All right, not green again. Okay, so green is 7, so we can either take the 7 and subtract from 25 minus 7, or we can add up 10, 5, and 3. Either way works because it's the same number. And so we ended up with 18 out of 25. And then again, we went back to the purple, which, you know, there are chances, or there are situations where there's 0 chance of that happening. So in this case, the same thing, there's no purple on our spinner. So again, its probability of happening is 0. All right, so now I just want you to look at a few situations and decide, are they theoretical? Am I going to base my probability on the item? Or is it experimental and I've got to base it on the data? All right, so the probability of rolling a 1 on a 6-sided cube. It's based on the item itself, so that one is theoretical. The probability of rolling a 1 on a 6-sided cube is a theoretical probability. All right, our second one here, after rolling a cube 10 times, the probability of getting a 1. So you had to do something. You had to do an action, so that one's going to be experimental. After conducting a survey on which sodas people like, the probability of the next person selecting a Dr. Pepper. Okay, so again, you've had to do an action, you've had to work through the survey, so that's going to also be experimental probability. And then the last one, the probability of spinning a color spinner and landing on red. Again, you're manipulating the item itself, or you're looking at the item itself, so that one's going to be theoretical. And as always, thanks for watching. Email me any questions or comments at bethemath@gmail.com.